Welcome, folks. Before I begin, I recognise and pay respect to the first scientists and acknowledge the important contribution this unique wisdom provides to contemporary scientific conversations and collaborations. I acknowledge the deep and timeless relationship between country and Aboriginal and Torres Strait Islander peoples, and pay respect to the elders of the community and extend recognition to their descendants, both past and present. Now, how many of you actively checked in on the weather this morning? Radio, TV, or if you're like me, firing up the bomb app on your phone with bleary eyes before you've even rolled out of bed? A lot of us humans are a bit weather obsessed, and not just when there are floodwaters rising or hailstones imminent. We live on the driest inhabited continent, but in a country the size of Australia, we get some incredibly varied weather patterns too, from the tropics to the deserts, right down to the snowfields. So, let's talk about it with two incredibly qualified speakers. My first guest here is a lifelong weather nut. He began his storm chasing career age 17. I want to know what your mum thought about that. And saw his first tornado in the USA in 2010, where he has returned yearly to chase them. Please welcome Justin Noonan.
Thank you very much.
I'm imagining everyone at home is wildly applauding right now. And my next guest has also been fascinated by weather since he was a kid. When he grew up, he began living the dream by working at the Bureau of Meteorology as a forecaster, specialising in severe weather. And you may know him from 7 News Brisbane. Please welcome Tony Auden.
Thanks for having me, Tegan.
More applause is happening definitely at home. We're going to have some time for questions from you all at the end. So if you've got a question, type it in the chat and I'll try to get to as many of them as I can. Now, the weather across the eastern seaboard of Australia and its effects has been pretty devastating in the past couple of weeks. We're going to get to the unprecedented rain bomb, as it's been called, but let's kick things off with the more usual daily weather. Tony, how do you actually put together the daily weather forecast? What's driving weather patterns?
Well, it's a very good question. Basically, we need to start with what's happening now and figure out what's going to happen later. So it's a complex process. Basically, modern forecasting started in the 1800s when people could finally communicate with each other. They had electronics, it'd be a telegraph. Mainly with military operations, we're seeing those advances in technology. It's not just a case of what's happening overhead now. You could send the information to someone downstream. So I think most of it was generally across Europe. You'd say, what's happening now? Send it a few hundred Ks down the way. This might be coming to you, and they could start to estimate how quickly systems were moving. Now, that's rapidly changed now. Of course, we have a lot of technology, satellites, not just the weather stations around, radars, and some of the biggest computers on the face of the planet are dedicated to weather forecasting, which I think Justin and I are very excited about. I've been inside the room that houses the Australian version when it was at the Bureau of Meteorology in Melbourne. The room is the size of 2 basketball courts and has probably one of the biggest air conditioning bills you've ever seen. It's a really big computer. I think a rough estimate that's calculating 1 billion calculations every second.
Oh my gosh.
So that's a lot of information. It's not just a 1 + 1 = 2. This is a lot of information. I might head up to the screen. I'll show a few little concepts. Happy to bounce off you guys and just show roughly what the concept is and how I'll incorporate that into my day. I spent a lot of time custom forecasting myself. I don't just trust the Bureau forecast because I think I can add a lot of detail as well. So we'll head up here.
Do the weatherman thing.
Exactly. I've got a point. So here we have some forecast winds from a website which is one of my favourites called Windy. We can get a lot of information. This is out of a computer. This is the forecast model information. Here we have wind strengths. We've got our east coast low, which has been bringing damaging conditions to New South Wales over the last few days. You'll see these squiggles here. These are the isobars showing the general overall patterns. We've got a high pressure system down here in the Bight, which is actually keeping things fairly settled across Australia. I was really excited to mention the high in the Bight for the first time in weeks today because it meant things were nice and quiet. But how do we get to this? This is an end product. This is what we're expecting through the course of time. Well, we start with those observations. So if we can have a look, I think we've got some maps showing the weather stations around the country. We have hundreds and hundreds of them on top of rain maps. Here we go. So all of these dots, obviously it's easier to get a high concentration around where we have population centres. A lot along the east coast, not too much in the middle of nowhere, out in the middle of the desert, but we still have some very valuable points there, and that helps to really create a snapshot of what's happening in the world right now. Here we also have some floating buoys. These fill in the gaps over the ocean, merge that with information from satellites and radars, and we get and actually a really important one, balloon flights from our airports. They give us an idea of what's happening vertically through the atmosphere. We do all of this, we assimilate it into a snapshot of what's happening across the globe at two main times. It's usually 00 Zulu, which is 10 a.m. here, and 12 Zulu, which is 10 p.m. And globally, everyone's reporting at the same time. And then we'll get into some more of these forecast charts here. So basically, we figure out what's happening now. They simulate that into a grid of what's happening. It goes into this supercomputer as a starting point. We work all of these billions of calculations, and you calculate what's happening at every one of these little grid points around the globe through height and through time. So you can imagine that's a lot of calculations. This takes the supercomputers potentially hours to calculate. We're waiting 6 hours on a European model to come in just for the bulletin at night. This is a simplified version. This is actually the Australian version, the Axis G, which is calculated locally. You can see these, this is basically a simplification. The isobars here showing where the big features are going. You've got some green and blue shades here showing forecast rain. On top of that, we can get forecast wind, humidity, you name it. We've got all kinds of stuff in there. Solar irradiation. Anything else obscure you can think of, Justin?
Oh boy, where do I start? There's too many, really, isn't there?
Well, basically, there's a lot of information coming out for all of these points, but this is just one solution to a problem. So here we have the Access, which is Australian model. We've got a European model, a UK model, an American one. And our job as a forecaster is to come along and look at all of these different solutions and say, what is my favourite? What do I think is right? What's working short term? What's working long term? So it's a real problem.
So you were saying that you get a weather forecast that's given to you at the Bureau, but then you're adding to it. Like, what are you adding to it?
For the most part, detail. So I can actually look at information on my phone 10 seconds before going on air. Some of these models are updated right on 6 p.m. It might change my forecast for the next day, and I can update that basically by saying it and showing it. So as good as the Bureau is, I help bring in their system. It merges a lot of information. It can wash out that detail, and just through the nature of the process, some of their information can be 12 or 24 hours old. So I'll bias mine a little bit. If I think, hey, this is something that's really updated, I can say, just watch out for that little afternoon storm in this area tomorrow, because the information's right to hand, and we can have some higher resolution information as well.
Yeah, right. Well, take a seat unless you feel more comfortable standing next to your big screen.
I'm happy to sit down, but basically that process is start with what's happening now, calculate things out, and then it's a case of merging which of these solutions do we like, which ones have failed in the past, which ones are good. And one of the really good examples for that was actually the flooding event. We had one of those 5 models was picking heavy rain across the inland catchments. As soon as I saw that, I was thinking major flooding for Ipswich, maybe something significant for Brisbane. All the other models had all this heavy rain on the coast, which would have been significant, but a completely different scenario. So we had to try and, well, both of us, figure out what was happening. We were comparing notes the whole time. Do you have a reason to trust this one? This is what my thoughts are. And basically go from that and use our brains to figure out what the computers are saying.
Yeah, well, Justin, can you talk a little bit about that and about southeast Queensland weather more broadly, like what we see here typically?
Yeah, absolutely. Well, we're in a subtropical area, so we get southeasterly trade winds. And that's what we're experiencing right now, as Tony just touched on, that high pressure system that's moving in. It's producing those southeasterly winds, which is a godsend for us right at the moment after all that heavy rain in the last couple of weeks we've experienced. So it's nice. It's a little bit calmer, a little bit cooler. But of course, when we get into thunderstorm season, we're looking for a few things and a southerly change, which was yesterday. We saw that. The timing of it was a little bit off for us, which actually saved us. But they are generally our biggest days. I mean, you think of the Gap Storm on November 16th, 2008, and of course, November 27th, 2014, that brutal hailstorm that went through Brisbane CBD, and of course, the damaging winds that moved through Archerfield as well, 170 kilometres an hour. So
I just love the way those dates just roll right off your tongue as well.
The official Bureau warnings on the Gap Storm back in 2008. That was my coming of age day, and it was pretty scary being on the desk and seeing what the radar was showing and what was actually happening outside the window in the CBD too.
I wonder, like, you have to make the call to make a warning like that. You don't want to spook people unnecessarily, and you also don't want to shoot your shot too early if it's not actually going to be as bad as you're making it out to be.
Exactly, and I've been asking that question of myself a lot in the last 2 or 3 weeks, looking at this situation, going, we have 1 of 5 is giving us, for want of a better word, Armageddon, a serious scenario. The other's giving us a slightly less scenario. How do I communicate this by, 1, staying within the confines of the official forecasts and warnings, and 2, outlining a low percentage but high risk scenario without everyone saying at the end, gee, you got that completely wrong. And it's a very tricky thing. Every day, every hour of every day, I'm saying, do I need to up this? Do I need to down this? Or downgrade this communication? So it's a pretty tricky line to tread when you have a lot of different solutions to the problem.
What does a typical southeast Queensland storm look like?
Well, for me, a typical southeast Queensland storm is a big supercell thunderstorm, which is the biggest storm on the planet, and they're the ones that create a lot of havoc. And I love to get out with my gear and my lightning trigger here and my SLR and a lot of other gadgets that I take with me.
What's the lightning trigger do?
So basically, instead of me trying to stand in front of the storm and take 1,000 photos at 1 second or something, this will actually detect it and it'll just fire off a shot for me. So I can just sit there and just turn this on and let it go, and now I get some fantastic daytime
You're that
lightning
person that
shots.
gets the really good forked lightning
I
shot.
try to, but yeah, so for me, chasing is the big supercells. I mean, I love shelf clouds or what we call outflow dominant storms, but I love the big gargoyle thunderstorms where you feel the warm, moist air feeding it, and you see it spinning, rotating with one big updraft that's just rotating around, and you get this giant hail that comes through. And for me, that's perfect as long as it's in the middle of nowhere. Obviously, when it's affecting cities and people's lives, you don't like to see that.
Yeah, we might come to that in a little bit. But I was wanting to talk to you, Tony, about the longer cycle of weather. So there's sort of like the rain today, but then these bigger cycles that we see over time. Can you talk about things like El Nino and La Nina and how that's driving weather patterns across a whole year maybe?
That's right. So I guess a lot of people probably would have heard of El Nino or La Nina. That's the main influence we have on our climate here on the east coast, but we also get contributions from the Indian Ocean and Southern Ocean. I think we have a couple of animations, so I'll get back up to my favourite TV here. Now this one here, we'll just wait for it to come up. Here we go. So this is a neutral situation. This is Australia. We've got South America here. Pacific Ocean, we normally get those trade winds that Justin was talking about. Beautiful southeasterlies like today. Now, in this situation, we've actually got warm water here. This is a neutral situation. Average rainfall, pretty normal conditions. Now, we'll move on to the next graphic. Basically, we get this oscillation of warm and colder water across the Pacific Ocean, and that will drive those larger scale patterns that we expect. So here we can see up in the top here, we're going towards El Nino. The red there, it shows that we're in a drier pattern for Australia. We get warm water over near South America. That changes the atmospheric circulations, cooler water here. And basically, one rule of meteorology, warm air rises. That can cover many, many sins. So here we have warm water, warm air. They get basically updrafts. We get more rainfall out towards the Pacific Ocean and South America. We get descending air here. That means less cloud and less rainfall. Now we're seeing that now as we move to the other end of the spectrum, coming down towards La Nina. That's what we've had last year and this year. We get the warm water over Indonesia and northern Australia. There's large circulation sets up. We get uplift, more cloud and rain, not all the time. What we've seen for most of this summer was cooler, cloudy conditions, which has been nice for my lawn, but of course punctuated with a huge flood event. And we do generally see with this warm water here an increased risk of tropical cyclones across northern Australia as well. It's probably been an average season so far, but we are still in the peak of the season being in March. So that's the Pacific Ocean, La Nina, El Nino. Now I'm not sure if we've got the diagrams for the Indian Ocean, but basically it's a similar concept over there. Basically we get warm water over near Indonesia that sets up a similar circulation, brings in wet weather from the Indian Ocean across Australia. More so affects southern Australia down in winter, their cropping season. But we saw a very dry Indian Ocean influence back in 2019. That was the main reason that we saw those record bushfires and really dry conditions. Another one of these things is the southern annular mode. And that's basically a look at how vigorous cold fronts are in the south. So when we get a really strong signal, we get more rainfall, more cold fronts coming up from the Southern Ocean, affecting Tasmania, Victoria, South Australia, but less so in Queensland. They're probably the main ones. On top of all of this, of course, there is climate change. We've warmed over a degree globally and almost a degree and a half nationally. So we are seeing this background warming trend, a general drying trend in southern Australia, wettening in the north. And of course, there is that risk that a warmer atmosphere, per 1 degree, we can hold 7% more water vapour. So when we get these big events, there is a risk that they could become a bit more intense.
Well, let's talk about some big events because we've got a storm chaser here in our midst, as I said before. And we've got some photos of you doing stupid stuff, honestly.
Well, one man's stupid is another man's gold.
Let's have a little look at you in your element, or in the elements, really.
Yeah, so I think the first one's going to come up is actually my second tornado from 2010. It was June 10th in eastern Colorado near the town called Last Chance. So a little bit too far away there for my liking, but not too bad overall. I was pretty excited, as you can kind of tell there.
So what, like excitement level, what we're saying, like maybe 7 out of 10?
Oh, look,
I've seen the other photos, so I know that.
No, definitely that's a 10 out of 10 excitement.
Oh, okay, all right. Well, let's keep looking then.
inside the eye wall. Official wind speeds of well over 150 k an hour. You can't even stand up. This is insane. Still want to go to Bowen, bitch? The raw power that is coming across. The rain actually hurts your face. It's like needles into your face. I love it.
I do love it.
Why are you out there?
We were in the
Weather.
eye wall at Airlie Beach there, just as Debbie was coming on shore as a Category 4 tropical cyclone. And look, you've got to make the most of it. I mean, we don't get that many here, and we had a nice open paddock there. We were well away from any danger. And look, I love being
You got your
out.
safety goggles on.
I'm just
do,
noting
of
those
course.
official cyclone safety goggles.
You've got to have it. And I'm an adrenaline junkie, and I love Mother Nature, and I love the power, and I want to be in it. I want to feel it. And for me, that makes me feel alive. And also, we're able to get out warnings and help the Bureau too with our observations with the guys from Oz Cyclone Chasers. So a crazy few days, and actually had to get home very quickly. Obviously, the floods that affected here in 2017, and our family farm, unfortunately, we lost everything from that event. But you go from one high to a devastating low. But that's Mother Nature.
And just quickly, that is one of the things, if we can get reports from within a cyclone, back when I was doing cyclone warnings at the Bureau, that really helps verify how strong is this thing. We have satellites that can give us an idea of what the circulation's doing, but if you get reports from inside, wind gusts or pressure, you can really verify exactly what that circulation's doing, and that helps the models pick up on it when we crunch those numbers again, and helps you forecast forward in time as well.
So talk about, we've looked at your lightning camera. I'm very impressed. I'm going to buy one. But what else are you using to measure those other, like things like wind speed and that sort of thing?
Well, within Debbie there, the guys from Oz Cyclone Chasers have a portable AWS with an anemometer. And so
AWS?
Automated weather station.
Right.
Sorry. And so it's basically picking up temperature, humidity, and wind speed. And one of the wind gusts they actually picked up was over 250 kilometres an hour. And that went straight back to Tony's point. They straight into the Bureau and straight into the warning to verify what they were looking at. But there's a lot of other things I take, not just the camera, and that I have GoPros, I've got suction mounts, I've got so many different microphones, I've got about 3 or 4 lenses, another one of these cameras, I've got a drone.
What does the microphone tell you? Are you listening for something in the wind?
Just basically to try and keep out a lot of that wind. So if I can do commentary, or for me, another great thing is when there's a fantastic light show going on and I'm getting cloud to ground lightning strikes hitting all around me, I want to capture it. I want the thunder to come through like you're there when my video comes through. And same with hail. When hail's hitting the rooftop of the car, that's one of the best sounds on the planet. It's just amazing.
As long as it's a hire car.
No, we better have a look at your car, because I know what your car looks like after a hailstone's hit it.
Yeah, there's a couple of big ones there. Cricket ball size hail, that was down in northern New South Wales on the 28th of October 2021. I lost my windscreen that day. That was a fantastic day for me. And that was actually a HP supercell, which is the most dangerous thunderstorm on the planet, particularly in America, because when you're trying to find a tornado, it's generally clear, you don't want rain around it. With a high precipitation supercell, all that rain and hail wraps around the rotating updrafts. You can't actually see what's inside it. The only way to see what's inside it
To go
is to drive
inside.
straight inside and get into
Oh
what's
my
called the
gosh.
bear's cage,
Bear's cage, okay.
aptly named.
Let's have a look at a few more of your exploits then. Yeah, a bit closer this time.
Yeah, so that was an EF4 tornado near Katy, Wynnewood, Oklahoma, May 9th, 2016. That's actually a very famous tornado. If anyone's seen Tiger King, that's the tornado from Tiger King that crosses the road there. Yeah, so that was an amazing day, and of course the Brisbane Broncos representing too. May 28th, 2013, Bennington, Kansas, EF3 monster. Me doing my happy dance, chasing there with thongs on there. Good safety, protective gear.
Very protective.
As you can see, I get a little bit excited. I mean, it's Mother Nature, I love it. That's how much I love it. That's my signature move when we're going out and about. And I mean, a big tornado, that actually didn't move for about an hour, and it dumped about 300 mil of rain in that period of time. And thankfully, I only hit a couple of fences and not too much damage-wise, so that was a good thing.
I want to come back to more of your tornado picks in a moment, but Tony, let's be serious for a second. You did mention before that climate change is driving more extreme weather. What are the forces that go into that? And can we talk a bit about the difference between climate and weather?
We can. So there's a lot of, I guess, confusion if we ask the question, why can you get the forecast wrong, but you're predicting a climate changing over all this period of time? Basically, it's a different problem. A forecast is an initial condition. What's happening now? Exactly where are these elements in a course of time? A few days, be it 3, 4, 5 days. Climate is basically a boundary condition problem. You're looking at an enclosed system, our climate. You're changing a few things, gases. We've got our, anthropogenic gases going in. We're burning fossil fuels. How does this change?
Anthropogenic being like humans
yes,
are making
human-induced.
this happen. Yes, yes.
Yes, so we're changing the composition. The entire energy within the system, the inflow is the same, but how does that change? So we can have confidence in these forecasts over time based on verification, learning over time, that we can have confidence over 10, 50, 100 years as long as we know what's going into that system. It's an enclosed system. We don't have to know exactly where every single element is, but basically the entire system as a whole is warming. Then the extra layers of research are going into how does that affect individual areas? How is El Nino or La Nina being affected? How is Australia being affected specifically? So we can have confidence it's happening. We've seen it. It's accelerating. It's going to be a problem that we will have to deal with. We've got solutions, which is probably a chat for another day, but we can have confidence that the science is rigorous enough. We know it's happening, and it's documented well enough that we've got a scale on what's going to happen.
Well, we've really seen it this last week or so in Brizzy. We've seen lots of flooding, not just in Brisbane, of course, down the northern New South Wales coast and further down as well. Sydney's copped it this week. So let's just have a little look of just before the flooding really hit Brisbane. You had your finger on the pulse, and here's the weather report from that night.
Now here's a look at the upper reaches of the catchment. Starting as far north as Woodford, that water flows into Somerset Dam and can be released down into Wivenhoe Dam, our biggest dam. That combines with a lot more water coming in from areas further west. At the moment, Wivenhoe is sitting over 180%. That water starts to combine with water from the Lockyer Creek here. That's coming in from the right of screen. That's the water we've seen around the Lockyer Valley, Gatton and Grantham, starting to merge with any releases from Wivenhoe. It's then expected to flow down the Brisbane River, past Fernvale and into where it merges with the Bremer River. And that's water coming from the right of screen past Ipswich here. It merges near Moggill, and we start to see the water from all three of those rivers really rising and ready to approach Brisbane. From here, it snakes its way down the Brisbane River, combining with water from local creeks and streams like Oxley Creek, past the Centenary suburbs, eventually through the Brisbane CBD and out into Moreton Bay. There's a lot happening. In this case, a lot of that water is coming from below Wivenhoe Dam, which is making forecasting this event so tricky.
When you were at meteorologist school, when did they teach you about rain bombs? Is that a technical term?
Well, funnily enough, we learned about rain bombs, but it's completely different to this. Basically, that's a microburst. This is something we'd get out of a thunderstorm. It's basically a small scale. It might be a couple of kilometres across. You can get photos of it, a microburst coming out. The rain bomb in this context here is not really something that we'd technically call. It makes sense in terms of what we're feeling, but I've been looking at heavy rain events, having worked at the Bureau in Queensland for the better part of 10 years, and since obviously in TV, I was lucky enough to work with a guy called Jeff Callaghan, who'd actually developed much of our cyclone warning system. One of the first days on the severe weather desk back in 2008, I think it was the start of the year before the Gap storm. I came in, Mackay had 625 millimetres, I think, in 4 hours, give or take. I came in, he was retirement age. He'd said, you've never seen rain like this. In fact, I don't think I've ever seen rain like this. People woke up floating in their beds.
Oh my gosh.
So we've got a history of big events in Queensland. The interesting thing for this event here in the last couple of weeks, it was very different to 1974 and 2011. As I mentioned there, the rain was coming in mostly below the dam. Of course, Wivenhoe filled up to about 185%. It seems like they had that under control, although we were sort of counting down the hours, looking at how much rain was coming and how much time they had to hold it. In the end, they did. It stabilised, but a lot of water coming from west of Ipswich, of course, the Grantham and Lockyer Valley flooding, all converging, as I showed there. And then the really, really intense flash flooding we had on Sunday over northern suburbs of Brisbane. My house is on a hill and it nearly flooded. We nearly had water in the backyard. It was just falling so quickly, the gutters and pipes couldn't deal with it. All the local creeks north of Brisbane became very, very dangerous. And in fact, I'm surprised we didn't see more people die, as many people that they did. Of course, all of that water all converging in one spot, and it has to go through Brisbane CBD and, of course, spill out into the suburbs, and that's what we've seen.
You mentioned your family farm got copped it a couple of years ago, but it happened again, didn't it?
It did, unfortunately, and just on Tony's point there, with the flooding out west, I was actually flood chasing. I was out at Grantham when it started. You can see some footage now. This is the family farm and the shed there, and we've been through a lot of floods there, and that was getting close to the flood height in 96, but that actually went about another 2 metres higher. As you'll see, we nearly the shed was nearly completely submerged. It wasn't, but in 2017 it was actually about a metre higher where it went through the top floor of the house, unfortunately. And this was the Laidley Creek when it was really rising in major flooding out there, and I was chasing and watching people trying to go through 40 centimetres of water. I mean, if it's flooded, forget it. Like, it's not worth risking your life. You don't know if the road's there. And I've seen too many people, even at Mum's place over the years, I've seen them drive straight into floodwater, and we've actually had to rescue them. And it's not what you want to be doing, so just please do not drive through floodwaters, whatever you do. It's not worth risking your life, or the emergency person that's got to come and try and rescue you too. So.
Moving water is surprisingly powerful.
It is.
Oh my
yes.
gosh, and I couldn't believe how quickly it rose. And I think we're probably going to get some questions about that rain event later, and make sure that you put your questions in by going to the chat box there, because we're going to allow some time for them at the end. But Tony, we usually are seeing thunderstorms with hail at this time of year. Where's the hail and how does it form?
Well, we're actually learning a lot about hail production as we speak. So when I went to school, the idea was that you get an updraft, a little hail nucleus would form, it'd drop back down, you get a little bit more, it'd go back up and grow, and you'd get layers. Having had a chat with a guy called Josh Soderholm, he's a researcher, we're actually sort of rewriting the textbooks as we go. So the idea is at the moment we get this strong updraft. It could be a couple of 100 kilometres an hour in the biggest storms. It goes up, it starts floating around up in the storm. You get areas of supercooled water and areas of dry growth, and you get these layers building, but it can actually grow so quickly falling back through a storm. We can see significant growth as it's falling to ground. So hail can grow. Basically, you need this supercooled water to get it going and a strong updraft to get things up and elevated. But I was lucky enough, I don't necessarily chase storms like Justin does, but I was lucky enough to go up to Yalbaroo, north of Mackay, where we had the Australian record hail size last year. And because of COVID, the researchers couldn't get up. I didn't know if I trusted the freezers of the locals up there, so we thought we'll do a story with 7 News, bring them back down, get them safely at UQ for the researchers. And the sheer size of these hailstones, 14, 15 centimetres. So we're talking, golf ball is 4 centimetres. We've got cricket balls is around 8. Justin's a good cricketer, by the way. We're getting to mango size and then bigger than mangoes. And so if you imagine these things, the heaviest one was about 800 grams, give or take. I measured it. I'm trying to remember 700 to 800 grams. Imagine 2 cans of Coke falling on your head at 200 k's an hour.
Thanks.
So just ridiculously dangerous. And what we've actually come from them is the researcher got up, spliced them, weighed them over the last week, and he's found the growth mechanism in the tropics is completely different to all of these other storms that happen in the US and down further south. We're seeing a lot more of this wet growth as opposed to dry. So what they're doing is modelling this, trying to understand it, and hopefully we can forecast it better down the track.
So is it like looking at tree rings? They cut it open and they can see the layers as they build up?
That's exactly it. I've probably got a picture on my phone from the latest one that I had. I call them my babies because I transported these things back home and kept them in my freezer for one night and then got them to UQ. But yeah, basically cut them in half. These ones in the tropics had less rings. There was only 2 or 3 rings, a really thick layer of growth per individual lot of growth. Whereas elsewhere you might get 10, 15 rings. This one only had 2 or 3.
Wow.
It's a completely different process, and trying to understand it, we're still learning as we go.
So we associate green skies with hail here in Australia, but you're a tornado chaser in the US. What does a green sky mean over there?
Well, it's a big red flag, particularly. It's what I love about with thunderstorms, and you can see here this is a tornado in the US, EF4, the same one that was on Tiger King we're talking about, across about 300 metres from us there, and did a lot of damage and destruction. It was rated on an EF4, which is the enhanced Fujita scale, and basically that gets rated on how much damage and destruction it produces. So you can get the strongest tornado in the world move through an open paddock, and if it hits nothing, it'll get a rating of an EF0.
Oh.
But yeah, this went through and demolished houses, and unfortunately someone did lose their life. But for green over there, when I'm chasing, I mean, it's going green, isn't it? Twister style. I mean, that's what you love. And because in supercell thunderstorms, you get these big rotating updrafts, or a great little acronym is called SLIM. So what you're looking for is wind shear, lift like a trough system that's lifting the air, because obviously 2 air masses can't go through the earth, so it's forced to rise, instability and moisture. You get those 4 ingredients, which we got with this one right here, this supercell out on the Western Darling Downs late last year, come together, and you get it how you can see it's physically spinning there, and they get these striations that you see, and they start to get those colours come through it as the sun sets and interacts with it and sends through these colours and sends through sometimes oranges and a lot of the green. And it's not always a precursor for hail, even though generally it is. but I will always test it out regardless. But it just gives it that spectacular colour when you're trying to take photos of it, or videography and that type of stuff, and just adds another element to it. But supercells are the biggest storms on the planet, and that's when you'll get a lot of those colours and you get the right ingredients. And that acronym SLIM is fantastic to have if you're ever looking for those ingredients.
So we're going to talk about a lot of different types of weather events, but Tony, I want to talk about dry lightning, because we haven't seen much of it this summer, but it can be the sort of thing that can start bushfires. What's going on where there's lightning without the rest of the storm?
That's right. So the Fleetwood Mac song is wrong. I'm trying to remember the lyrics off the top. Yes, that's exactly that. Every time they play that, I think that's meteorologically inconsistent.
You'd call the radio station and be like, you've got to stop playing that song.
Yes. So basically, generally for Western Queensland or Western New South Wales, you get high-based thunderstorms. They're much, much higher than normal. You're raising a parcel of air 10,000 feet rather than 3,000 or 4,000 feet. You might get a thunderstorm top, and then you get a burst of wind coming out the bottom, but anything will evaporate as it comes out the bottom. Here we can see some sort of high-based storms. In fact, I believe, Justin, this is your shot that was featured on the Bureau website.
That was, yes.
Piece of lightning there. I know who's got a lightning camera.
That was out of Gundawindi on the January 15th, and it's just to what Tony was alluding to there. I was actually out chasing further west at Boland and stuff the day before, and we were getting high-based thunderstorms for that exact reason. We went out there to get that high lightning because the bases are so high, you get these really clear strikes just like that because of all the lack of rainfall that's associated with them. And that's the prize with storm chasing, when you're actually able to go out and get those type of scenes. And I mean, it's Mother Nature in its greatest form. You have front row seats to the best show on the planet. Like you really do.
Chase it.
Well, absolutely. Yeah, if you're prepared to pay the fuel prices for it, of course. So,
and of course, the visibility is high, but so it's great for photography. But if you don't have any rain under a storm to stop a spark from a lightning bolt getting going, we can see some of our biggest grass fires, especially through Western Queensland. A dry year, 2019. You got thousands, millions of acres of dry grass. You get one spark, and that can start a fire that lasts for weeks, if not months.
But it is, oh, here we go. What are we looking at here? That's stunning.
So that's a striated shelf cloud. That was actually between Cunnamulla and Boland just early this year on January 14th. So that started out as those high-based thunderstorms Tony was mentioning, and it grew upscale into the evening as what we call a low-level jet intensifier, which is winds a couple of kilometres up in the atmosphere, strengthened nocturnally at night. And as that develops, helps produce a line, and it interacts with quality moisture or better moisture and starts to lower itself and produce these. Another big epic shelf cloud that moved over Brisbane late last year in December. That was actually a very destructive storm.
Right, so what's happening underneath the shelf?
So underneath there, when it actually comes over the top, it kind of looks like a whale's mouth underneath. You get a lot of turbulence. Clouds are rolling inside it out. Almost looks like it's rotating, but it's actually not, and can be misrepresented for that. But that you get a little bit of calmness as that comes through. All of a sudden, you get hit with that much cooler outflow air that thunderstorm's trying to push out ahead of it. And that's when the damaging winds can be moving through, particularly once that rain shaft starts to hit you, and then you get the hail as well on the backside of it. So they're fantastic to look at and view, but they can be very, very destructive.
So you're saying this one's not rotating, but when we're talking about really big storms, we're often thinking about something that's turning like a cyclone or a tornado. Why does it spin?
Yeah, well, there's a few different reasons. There's a lot of different types of thunderstorms. You have a single cell, which is just one single updraft and one downdraft, and you get a lot of those. A lot of people probably see the radar where they see these little storms pop up and they kind of die again, because as they go up, because there's no wind shear to help push them along, the rain falls straight through the updraft, chokes it off.
Heating forces, and it essentially peters out.
Yeah, absolutely, yeah. And then you get these ones that are what are called multi-cell thunderstorms. So there's a lot of different updrafts competing for all that air, and eventually they can line out like it has here. But then you get the supercells, and that's just one continuous rotating updraft. And when you get that wind shear, the lift, the instability, and the moisture, most importantly, SLIM, it starts to rotate, because when Tony was talking about some of the balloon that goes up around the world, that gives you a vertical slice of the atmosphere and sends out what we have a sounding. So if you have winds coming in from the northeast at 20 knots, you go up a couple of kilometres and they're coming from the north at 30, another couple of kilometres and going up at about 50 from the northwest, and then even higher up at about 100 knots. All of a sudden you're getting rotation through the atmosphere as well as strong winds. So as that happens, it starts to rotate and interacts, and you would see it on the radar. If you see a lot of thunderstorms in southeast Queensland moving from west to east, and one will deviate and go to the northeast, it's going against the mean flow, so it's a fair chance that's a supercell. And they're the ones as a chaser you want, but they're also the most destructive. They put on these fantastic shows, but they're a violent storm. One rotating updraft, and there's 3 types of those. An LP supercell, which was the photo over at Goondiwindi with the lightning. That was an LP supercell. You have a classic, which is beautiful. That's the ones you want. They're the best ones for photography. That's the LP.
I don't mind LPs myself.
Yeah, no,
LP's low
precipitation.
Low
So you've
precipitation.
got clear air around it, you can see
Yeah.
more structure.
So you can see the perfect structure of the updraft there where the lightning is coming out of the base. You can kind of see the tilt of the updraft as it goes up and then the rain curtain off to the left downstream. So a classic is very similar. There's just going to be a lot more rain involved with it. And then you get the high precipitation ones where you really wouldn't be able to see what's happening under that updraft. Sometimes I've noticed actually there's a lot of LPs that we get here in southeast Queensland that you don't actually see any rainfall coming from it. But boy, there's some big hail falling out of it. And that's where you need to be very careful of. They are big hail producers.
So what I've mostly learnt from this session so far is if you're running towards something, I should be running in the other direction.
Pretty much,
Go
yes.
the other way.
So as promised, we've got questions coming from you guys who are listening at home. Please keep sending them in by going to the chat. And but I'm going to start with this one that we got from Facebook ahead of time. Megan's asking, as unprecedented, we keep hearing that word, weather events become more common with the impact of climate change, will technology get to a stage where we can predict it sooner and maybe help people preempt and prepare for such things with more notice?
Short answer is yes, we are improving. Having said that, we are within a very complex system, so there are limitations. You might have heard of the butterfly effect. Chaos theory, you've got so many different unknowns in this system. So we're looking at weather stations that might be 10, 20 k's apart. Grid points on a model might be a few hundred metres at best, a few kilometres apart. So you've got a lot of unknowns in there. We're improving our skills. We've got bigger computers. In terms of the analysis, probably the same. We're all skilled. We know how to deal with what's coming at us. But we're currently, I don't know the exact stats, but I can confidently forecast out to 7 days in some situations. In fact, Cyclone Yasi, back in, 11 years ago, that had a bullseye 10 days ahead. It picked a coastal crossing within 6 hours, within 100 k's as a big Category 5 system. That's the best forecast I've ever seen. It didn't change. This is 10 years ago. We have much more powerful computers. Having said that, you get a storm cell that's erratic. You might not be able to pick which suburb is picked, hit by a cell, and which is missed half an hour ahead. So every weather situation is different, but essentially as technology improves, we are getting better and a lot better.
We've actually got a question that I think we have a photo for. Narelle's asking about tornadoes. She's never really heard of these occurring in Queensland until the last 5 or 10 years. Here's the Brisbane Tornado. Do you want to talk us through what we're watching here?
Absolutely. I'd love to actually demonstrate on this one. So the myth about Australia not getting that we don't get tornadoes is completely false. We do, and we average around 70 to 100 per year. A lot of them are obviously areas we don't kind of see. And so this was the Brisbane Airport tornado, and you can just kind of see it here, but hopefully I've missed the first part, but if we're able to just jump back, I'll be able to show you all that warm air that's flowing into the thunderstorm. So here you can see all of this warm air is flowing in. You can see the trees bending, and the rotation is wrapping back and around here, and this is the tornado that actually went through the airport area. So to see that within 5 kilometres of the CBD is staggering, and I never in my wildest dreams thought that would actually happen. But yeah, we've seen a lot of them this year, tornadoes, and you actually see a lot of waterspouts. I've seen about 20 waterspouts off southeast Queensland in the last 2 years alone.
Can you talk about what a waterspout is?
Yeah, so basically it's a tornado over water, but it's not formed from a supercell. So this is formed from a supercell thunderstorm. So waterspouts actually originate from the surface, same with landspouts from the surface, and then go up and towards the cloud. So you need specific ingredients on a day where there's light winds, a little boundary. We actually discussed it the time when it happened, where we had this little westerly boundary as it interacts just off the coast, and Coolangatta and Tweed is a fantastic area for that.
I've seen them out in the surf a few times.
Yeah.
Really?
Generally, it's the same idea of spinning air, but the driving factors are generally a lot weaker.
Yep. Yeah, but they can still cause damage, but yeah, they're much weaker on the scale overall, and but they're still just as cool to watch. So I actually saw one off Nudgee Beach again just back in February too. So
That's cool. So a question from Matt saying, can you explain how ball lightning forms? Or maybe we should start with a definition.
That's all on you, Justin.
ball lightning. Look, I've heard people that have seen this before and have spoken about it. I don't really know the mechanisms behind how it develops. It's probably very similar in the way that all lightning works, I suppose, with positive and negative charges, and obviously the cloud base is negative and we're positive here, but ball lightning is a different entity in its own right from all reports, and I've actually got a couple of friends who are lightning experts, and they're still trying to work that out because they've never even seen it either. So that's a very tricky one. It's actually one I don't have an answer for, and I feel pretty bad about that.
Sorry, Matt.
It might be the edge of our understanding, though. Like I said, we are still learning as we go, and things like ball lightning are probably not fully understood yet.
So a question from Lily saying, Tony, why was forecasting the recent weather event so tricky?
Well, I sort of alluded to this before, the fact that we had a situation where we thought something was coming, but we had 4 or 5 different models, a few more as well, but one was painting a really nasty scenario, the others were painting a different scenario, but the one that was painting the worst scenario is my favourite model. So I was sort of slanting
your favourite way of interpreting the data that's coming in?
Well, my favourite, if I had to pick one of them and said this is the answer, this is my go-to. Like, this is my first reason to track. So this is the European model. It comes out of a big computing centre in Europe. It's generally been the best that I've used for the last 10 or 15 years. At times, it'll go off, and I'll think which models are verifying better, and I'll slant my forecast towards that. So the main thing is you've got this, in theory, low percentage but high risk. So I kept on tracking. I think 4 or 5 days ahead, I said, this is a possibility. Next day, I said, this is looking more likely, but we have this nuance of, is it coastal rain? Is it inland? And then I think Wednesday, we're expecting the rain to fall, and it just didn't. This little trough went offshore. It was a false alarm. I said, just wait, we've still got a few more days to go. The Thursday was meant to start warming up. It didn't happen for another reason. And then this model went off for one run. So it's updated every 6 hours. It went from 500 millimetres to 50. And then I'm thinking, okay, we've still got this potential. How do I word this? So on air, I said, look, there's been a downgrade on this, but we still have a lot of ingredients around. Watch this space. There's still something potentially on the way. And of course, history will show that we had falls up to 1,700 millimetres plus at Mount Glorious. So it ended up being the right one. It was one out of 4 or 5 big ones that I look at that picked it best, and then it had a crisis of confidence for 1 6-hour period and then went back onto it. So devastating results. And like I said, it was low percentage, but really high risk.
Staggering about that, it was around Sunday, I think we were only looking at probably 50 to 100 millimetres of rain. There was going to be a lot of shower activity, but I think we were actually discussing it to each other late Monday into Tuesday about this massive upgrade in the models, and it kind of got you a little bit nervy because you're like, some of the figures that were spitting out, you're like, that can't be right. Like,
well, in fact, I saw some model runs that were over a 36-hour period, so a day and a half going for 900 millimetres, and I'd never seen that before. And my thought was, how do I deal with this? Do I pick a middle point between my normal reality and what this is saying? In the end, the first run didn't do it, thankfully, because that was headed straight for Justin's farm. But we did see similar stuff further north, so north of the catchment and northern suburbs of Brisbane into the Pine Rivers. That Sunday where we saw the flash flooding, who knows what the peak rainfall was, but we were seeing over 100 millimetres an hour for 4 or 5 hours on top of 71 hours of rain, continuous. So this is a very top-end event, and I stopped talking about numbers and said this is the period of time that we can get rain. Anything can happen in that time.
How has your interpretation or the way you communicate forecasts changed from when you worked at the BOM to talking directly to the public on the news?
I have a lot more freedom now.
Oh, really?
I can take a pick. I can not sit on the fence. Obviously, being the official forecaster, there has to be a certain amount of responsibility in terms of we're covering all bases, and just the forecast systems are that way. Now I can trust myself. If I've got an outlier, I've got the time to say, look, this is the most likely scenario. It's not too bad, but just watch this space. We've got this one potential scenario that could happen. I'm not sold it could happen, but if it does, we've got big issues. So just keep an eye on it. I'll usually get people to keep tuning in. I'll keep you updated over the next few days. And refine it as we go. Like I said before, pretty much every hour of the last 3 weeks, I'm thinking, do I need to upgrade what I say? Do I need to downgrade it? Is this realistic? What is the threat?
A question for you, Justin, from Lee. I'm not sure that you're a very trustworthy source. Lee's asking, can you share any safety tips when it comes to storm chasing?
Oh, absolutely. Look, there's a few of them. And one of the most important ones, particularly in Australia, is watch out for your surroundings, particularly where you go chasing. I go chasing a lot in Western Queensland, New South Wales. Snakes are a big issue. It sounds very trivial.
Thongs might not be so safe.
Look, I've stopped doing that now. I've matured a little bit. But yeah, look, that's a big thing. Obviously, for me, I can tell you where hail will fall, where a tornado will develop, where rain's going to fall. I can't tell you where lightning's going to strike. And that, for me, is the biggest fear when I'm out chasing. I've had numerous close calls with big bolts out of the blue well ahead of the storm that hit behind you. So that's probably my biggest tip, is just be very careful lightning, particularly if you're getting close to the updraft and the downdraft area right next to it. That's a lightning-produced area. But you just got to keep your wits about you, and that's obviously hail is a big one too. If you do get smacked with hail, You want to be prepared. And flash flooding's a big one too, particularly out in the Darling Downs. It's a lot of flat roads that flood very easily. It only takes 50 mil of rain in a 30-minute period with a severe storm. So there's a lot of them. And you just got to keep your wits about you. But if you're looking to do it for the first time, be very cautious. Just stay a little bit further away, and you're going to have what we call a bust. It's when you go out there thinking you're going to see this beautiful storm and you don't. And look, it happens to everyone. It still happens to me. And anyone that says they don't bust, they're lying, because it will happen to you. And you just got to be patient. It took me a long, long time to have the knowledge that I do today. I mean, I've been chasing storms for 20 years now. First time I went chasing, I had no idea what I was doing. I had my underwater disposable camera and my old ute when I first turned 17, and I've still got that photo today of a pretty little guster, and about my next 3 chases after that were busts. But you actually learn more from a bust than what you do a successful chase.
Right, so there's the science on one hand and this sort of spidey sense that you develop over time.
Oh, yes, yeah. And you get so experienced over time, you can tell whether or not one updraft's going to go through and produce a thunderstorm, or the next one's not, or this one's going to go severe. And it just comes, you get the look about certain clouds and thunderstorms, and you can tell if they're drying out or if they're not, or like yesterday, you could tell it was a little bit dry here in southeast Queensland where the westerly winds just invaded a little bit too much. So you just kind of get that knowledge about you, but you just got to keep your wits about you and just stay safely out there, Lee. Like, enjoy it, enjoy Mother Nature in its greatest view.
Well, we've got heaps of questions coming in the chat. Keep them coming, we've still got time. We've got Cal Nitch asking about what is cloud seeding and do Australian governments undertake this?
Well, we did actually have a cloud seeding experiment using the official backup bureau radar back when I started a bit over 10 years ago, maybe 15 years ago. There's a big dome on the hill at Regbank Plains here in southeast Queensland. I'm not sure if it's still there, but basically we had a pretty detailed cloud seeding experiment. I believe the results were that there was nothing significant. We can't really change the climate, but it's been an interest in, I guess, authorities for centuries. Basically, we've got, I think, some famous rain guns out near Charleville that they tried to use to seed clouds and get rainfall from a century ago, because when we get droughts, they last a while, but there's so much land that we could potentially use. As far as I know...
To interrupt, can you talk a bit about what cloud seeding is, like what you're trying to do? You're trying to start the moisture accumulating,
Exactly.
right?
So the idea is you need a nucleus to get a raindrop forming. The idea is if you put some small particles in the air, I think it was silver iodide, I'm not sure exactly what it was. So we had planes going around and seeding existing clouds that were forming across southeast Queensland. They did a really detailed study with a radar and found, in this case, no real difference. But the idea is if you put more particles in there and you've got water vapour, you can grow more raindrops. On the other hand, if you have more particles, you've only got so much water vapour that can grow onto them. They might not grow as big and you're less likely to get rain. From what I know, it's not successful. Otherwise, we'd have a lot of money and success in being able to make it rain where it doesn't. So it's an interesting concept, but I don't think it's going to be any significant change in how we deal with our existing weather and climate.
That's a shame. JK's asking, I'm going to ask this one to you, Justin. How close have you come to being struck by lightning?
Very close, within 100 metres. Yeah, it was a couple of times, and the one that I remember the most was in the US in 2016. I was forecaster for a storm chasing tour company over there, and there was about 20 of us on the side of the street, and I could see all my hairs were starting to stand up, and that was a danger sign for me. And I said to everyone, I'm like, in the car now, everyone's got to get in the car. A few people chose to ignore it. I got in the car. One of the people actually on tour took a photo, and you can see the leader, one of the leaders coming up right in front of him, but the strike actually hit another one behind us.
Talk about what the leader is.
So that is basically, that's the charge coming up off the ground to meet the bolt. It obviously doesn't make clear contact to the ground. There's a little leader that comes up and it chooses the path of least resistance. Thankfully, it wasn't that one. It was the one behind us. Otherwise, it would have been about 20 people flat out on the ground. And I mean, this leader was metres in front of the camera. So that's probably the closest I've ever had, even though I was in the van at the time, so I was safe. But there's been a lot of times where I've been watching and you'll see this big anvil and the big bolt will come and hit behind you. You don't physically see it. You hear the crack.
We had the longest distance lightning confirmed in the US, I believe, a few months ago. I can't remember the distance, something like 700 kilometres.
Yeah, it was something crazy across...
From the top of the bolt to the bottom?
From an anvil across horizontally away from the storm, across 2 or 3 states in the USA.
Across southeastern parts of the US, yeah.
What's an anvil?
So basically, like a blacksmith's anvil.
Yeah.
So when the thunderstorm goes up, it goes up into the much colder air aloft, which is the instability. And as it goes up, it gets to an equilibrium level. So it's basically hitting a layer of warm air way up high in the troposphere. And so when it hits it, it just can't go any further, so it spreads out. It spreads out like the blacksmith anvil. So, and sometimes when you get a really strong updraft, you'll get a little dome that'll punch through it, and you can actually see it from 100 kilometres off in the distance. But they're really cool. And then underneath that anvil is when you get the Mamatus clouds. You would have seen recently.
The ones that look like noses.
Yeah.
Well, they're called Mamatus because they look like...
Yes. Oh, I was a little bit worried about saying that. But yeah,
like breasts.
they're spectacular clouds when they're sunlit. But that's what happens. They form on the underneath side of the anvil as well. So they're so cool.
That's awesome. What about you? Been struck by lightning yet?
Thankfully, no. I haven't been chasing nearly as much as Justin. So within the normal realms of my life, I've been a lot further away than a few metres, thankfully.
That's lucky. So Mike is asking in all caps, I think it's in relation to what you were saying about bringing hailstones back down from North Queensland. What do UQ do with hailstones?
Well, they measure them, they splice them, they get an idea of, I talked about these rings, how they formed, and I believe there's actually some research going on where they can model the actual shapes, put them in a nested model, a really high resolution model of an individual storm, and start to figure out exactly what the path is through. It's a bit like the end of Twister where they release all the little things and they get an idea of exactly what's happening inside the tornado, albeit a different way of doing it. But that's the kind of scale that we're getting to now, where we can run really high nested, high detailed models and use the exact shape of a hailstone and see how they reckon that's going to form and flow through a storm and then drop where it dropped.
Super cool. Super cool.
That is really cool. Why do some suburbs in Brisbane seem to get worse storms than others?
I'll let you take the lead on this.
Okay. Well, that's an excellent question. Look, there can be little things on a mesoscale area that depict exactly where thunderstorms may go. Obviously, southerly change. There's a good old dome around Brisbane that likes to split or constantly.
It's over my house.
It does. I'm sure there's actually something needs to be looked into that for Brisbane. I'm sure of it. Yeah, look, there's sometimes topography can play a part in that. Little mountain ranges can split around because you get all these areas of wind that are funneling down. It can sometimes split around and move around. And you do get hotspots, like Boonah was always a hotspot. The Brisbane Valley's always been a hotspot for severe thunderstorms. We get a sea breeze front, so those storms can blow up along the sea breeze front and go violent very quickly as they interact with that more moisture coming in off the Coral Sea. But look, it's a little bit of just a hit and miss scenario too.
I'd argue that the topography from me looking at radars for years and years is probably the main one. You get certain ranges in certain areas. If storms split, you'll get a right mover, supercell, go down to the Gold Coast, and the left mover go up across the dams and up towards the Sunshine Coast. And this is why we have a bit of a dome over Brisbane. Other factors at play, but I think topography is why we see a lot of repetition in terms of those storm tracks.
How does that play into how you put your forecast together? Sort of that knowledge that you've seen from looking at Brisbane, because Brisbane's, well, Southeast Queensland's a pretty big place.
For me, I think most of our forecasts will be broad brush enough that we cover all areas, but most of the locals will know, hey, from this direction you've got a southwesterly steering. This is the way the storms will go within reason. We don't really have enough products that we could put out that resolution where we say, hey, it's going to hit these ones. I will put on social media, sometimes we'll have our high resolution Australian model. So this is a nested model just over Brisbane, Sydney, Melbourne. It tries its best to pick up individual storm cells. I'll put that up with a big asterisk saying, hey, this is one scenario to give you an idea of timing and where storms will go. Sometimes it's been amazingly good, even in terms of picking some of the peak rainfalls. Sometimes it's a complete bust as well. So it's very much this is trying to pick up those very small scale things, and it's sometimes does it, sometimes doesn't.
We've got a question from Zara about the variations in places and the weather that they experience. Why does New York get hotter than Brisbane in summer, but they get snow in winter and we don't?
Going to take the lead? I've been to New York where it's been really stinking hot. Look, one thing, you get a bit of an urban heat island, which makes things hotter, but that's not the main influence. I guess it's prevailing conditions. So the USA has really strong contrast in their weather from the polar vortex to the tropics. And another thing, the northern hemisphere, because there's so much more land, what you get is those big scale, the cold fronts circulating the globe. In the southern hemisphere, they tend to go west to east a lot. Every now and then you get a bit of up and down, which is when we generally get severe weather.
When you're talking about up and down, like
north and south.
What is going up and down?
Cold fronts or the large-scale waves around the North Pole and South Pole. So a cold front coming up from the Southern Ocean for us. Because there's less land in the Southern Hemisphere, we tend to get winds will go west to east. They don't bring up the cold as much. They don't bring the hot down. In the northern hemisphere, you've got the Himalayas, you've got land all around the globe. You get a lot more ripples, we'll call it, in those waves. So you get colder air coming down from the North Pole and hotter air coming in from the tropics. So that's probably one reason why areas like Europe and the USA can at times get a lot of extremes.
JK's asking, I'm assuming this is for you, Justin, how many cameras have you been through?
A few. I think this is about my 4th or 5th. I've gone through about 7 GoPros.
What happens to them?
Well,
Hailstones?
I left one on the roof and forgot about it, and it flew off. But a lot of them just get damaged. I mean, because I don't just chase storms, I do volcanoes too. So you get little bits of ash that get into it.
There's a whole nother seminar on volcanoes.
Rain, they get damaged because I stick them out in rain as well. Sometimes if I'm trying to get the perfect shot, I'll have a tripod on the ocean or on the sand, and just a lot of stuff that just gets involved and gets into it and inside the lens and in the cases. And rain's probably the biggest thing. When you're trying to get the perfect shot, there's just always seems to be raining.
Well, okay, so you don't chase volcanoes; they're already there. But how does a volcano affect the weather around there? Imagine there's a huge hot air rising up. What's that doing?
Well, obviously with the Tongan volcano eruption back in January, you saw there was actually a supercell thunderstorm that formed above it because of how hot it was and going up in such a colder atmosphere. And it had an anvil pop out of it, and I think it produced 100,000 lightning strikes
A lot of lightning.
in an hour or something crazy. That's an extraordinary amount of lightning. And so look, they can produce like acid rain, those type of stuff, that type of
it's
stuff.
mixing with the ash that's coming out?
Yeah, well, it's just all the gases involved as well. So I'm certainly no volcano expert when it comes to that type of stuff. But yeah, there's a lot of the elements that go into that. I know the people in Vanuatu, which is a place I love to frequent, Maram volcano produces a lot of acid rain. I've had friends that have scaled that and they talk about it all the time, and it decimates the areas and the crops and that type of stuff. And obviously the real big eruptions that we've seen in history can actually lower global temperatures. Mount Pinatubo, I think it was like 1 degree.
Krakatoa.
Because the ash clouds reflecting the sunlight.
Over the course of a few years. One of the other things with the Tongan volcano is we had this pressure wave came out, which you couldn't necessarily feel. Some people could hear it on the Australian east coast, apparently, which is hard to fathom. But it was measured going around the globe. It was measured in Europe, and I believe that even went around 2, maybe even 3 times and measured on instruments.
Still, I think even up to last week, some of the sunsets we're still seeing a little bit of ash way up there, and beautiful sunsets when you get it, but violent eruption.
And a question from Emily to both of you. What is it about the weather that interests you most?
For me, it's the fact it's always changing. So technically my job is the same every day. Come in, forecast the weather, get up and talk and point. But no 2 days are the same. You're figuring out what's happening, not just taking the icons that are given to me. I'm trying to add as much as I can and always learning. You can't stop learning.
I love how small and insignificant Mother Nature makes you feel. I mean, a lot of the ingredients we talk about when it comes to thunderstorms, you can't physically see, and the only way that it can manifest is a violent thunderstorm. And when I'm literally there watching it, I mean, that's bliss for me. That's my form of camping, basically. I'll get away from it all and just enjoy it. And that's what I love about weather. It's just the unknown, seeing all the elements come together, and it's heaven.
Well, we've only got a couple more minutes left, so I want to finish with a bit of a, oh my gosh, lightning round. Sorry. I'm going to start with this question from Claire. Can it rain fish?
I believe it's happened, and it wouldn't surprise me given that big thunderstorms can pick up trucks, but I wouldn't know the exact processes, but given the strength of updrafts, I'm sure it can happen.
Anything to add to that?
Oh, I've actually seen tornadoes do it before. Over in, I think it was in the UK, I've seen fish put up on the side street from a waterspout. So,
someone's asking, what is diamond dust? Like a frozen fog.
I'm not familiar with that.
No.
We'll have to
I've heard that term.
question without notice. Is a firestorm a weather event?
It can be. You can start with a bushfire that then creates its own pyrocumulus or pyrocumulonimbus, its own weather events. And
So pyro, fire,
exactly.
cloud.
So the updrafts can create their own clouds, which then can create more dangerous fires because you get embers flowing out and stronger winds. So a fire can definitely create its own weather.
Canberra 2003 produced a tornado from a firestorm, a supercell born from a pyrocumulus. Actually chased one on the Darling Downs in 2016 that was producing lightning and went on to produce a big cluster of high bay storms. So.
If you think a tornado is scary, a fire tornado is
That sounds
horrifying.
absolutely
Horrible.
terrifying. Can big cities affect local weather?
Absolutely. I mentioned the urban heat island before. We see temperatures in and around concrete higher, and even the simple thing of rainfall and flash flooding. Rain doesn't absorb into concrete. It has to go somewhere, which is why it's really risky when you get heavy rain through streets of suburbia and the cities. We need really good drainage systems.
And one last question for you, Tony. Is it going to rain tomorrow?
Short answer, yes. A couple of passing showers, maybe a little rumble inland in the Aho.
I thought you were going to say yes somewhere in the world.
Not that vague. No, we'll have some passing showers, but nothing compared to what we've had for southeast Queensland, at least.
Well, don't wash your car then, folks. Thank you both so much for joining us tonight.
Pleasure.
Tony Auden and Justin Noonan. Thanks for joining us. Hope your rest of your week is fine.